Okay, let's go ahead and do this first one. So I want to convert this this density unit into a different density unit, one that we're more familiar with. So I'll go ahead and start off with 2.34 tons and yards cubed. I'll convert the volume unit first for no real reason other than just whatever. So 1 yard is equal to 3 feet. And I'm doing that because I'm trying to get over to the metric system and I need to get through inches and centimeters to do that. So I'll flop those guys over. What happens if what happens at this point? What have I done so far? I've only taken care of one of the 3 yards because that yard on the top is 1 yard to the first. So I can change that and just go ahead and say it's yards to the third, first to the third, third to the third, and feet to the third. Or you can write it 3 times, but I think just writing a bunch of 3s is a little easier. So now that we've done that, I can cancel out this yards cubed, and I have feet cubed, which is closer, but not what I want. So then I'll have to put feet up here, and then I'll go to inches down here, and 1 foot here, 12 inches here, and then we're going to do that same thing where we cube everything. And then I can cancel the feet cubed out with the feet cubed. Still not done. So 1 inch is 2.54 centimeters. And then we'll go cube, 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 cube. And I can go ahead and cancel out the inches cubed, which is good because I'm finally left here with something I want, which is centimeters cubed. And then we can move on to the tons part. And so for every 1 ton, you've got 2,000 pounds. And then for every 2.2 pounds, there's 1 kilogram. And then for every 1 kilogram, there's 1,000 grams. And so that allows me to cancel the ton out, the pounds out, and the kilograms out. And here I'm left with a unit that I'm looking for, which is grams. So I've got grams divided by centimeters cubed. And so let's see, we got 2.34 times 2,000 times 1,000 divided by 2.2 divided by 2.54 cubed divided by 12 cubed divided by 3 cubed, and it looks like 2.78 would be my answer. Okay. Do we have any questions about that? No? Okay. So I'm going to rearrange this next equation. I'm just solving it for temperature Fahrenheit. So the 9 goes up, the 5 goes down. So I get 9 times degrees Celsius divided by 5. And then I'm going to have to add 32 to both sides. And that's going to leave me with a temperature Fahrenheit. That's as complicated as the algebra gets in this class. Okay, how about this next one? Are you all excited? For America, sure. Yeah. Unless you live in Montana, still kind of fast. But it's not super fast. We're not talking 125 miles per hour. So since you're in Canada, it's kilometers per hour. So 125 kilometers per hour. 1 kilometer is 1,000 meters. And 1 meter is 100 centimeters, and 2.54 centimeters is 1 inch, and 12 inches is 1 foot, and 5,280 feet is 1 mile. And then I can cancel my kilometers and my meters and my centimeters and my inches and my feet. And that just leaves me with miles divided by hours. And it works out to be 77.7 with the correct number of sig figs. That good? Any questions about this one? Okay. So how about this question? Nope. Yeah, there's a question up there.
Yeah, my brain couldn't get it.
Okay, so I want this to float in a river, probably of water, not something like mercury. So how's it going to float? Okay, so if this phone plus case have a density that's less than 1 gram per milliliter, then this thing's going to float. It could be 0.999999999, it's still going to float. All right. So what I know is the phone has a mass of 135 and the case has a mass of 45. So that means the combination of the phone and the case have a mass of 180 grams. So I'm looking for a number with units of grams per milliliter. The gram portion of this is 180. And I need that number to be less than 1. So I get to pick any milliliter number I want. What are you going to pick? $200? That would work. Anything else work? Anything larger than 180. So if this was 180.1 milliliters, that case and phone would float. That's all we were looking for. So the answer to this question would be anything greater than 180 milliliters or 180.1 milliliters or 200 milliliters. Any of those things would be fine. Although, wait, no, I said minimum case volume. So minimum case volume, I guess that's kind of nebulous. Could have just said greater than 180 milliliters, and that would have been totally fine. And there is a iPhone 5S in a perfectly good, completely waterproof case somewhere in the Columbia. Not floating. Not floating. Okay, how about this next one about the Greek and Dalton's theory of the atom? Questioning structures? The fact that their theory was correct is pretty awesome. I mean, there are lots of other theories out there that people used. I mean, one called phlogiston was around for more than 100 years, and it was completely wrong. And there are textbooks talking about phlogiston, and there are very famous, important chemists and physicists that believed in phlogiston and did lots of other good work. They just were wrong about this thing. Like we were talking about Crux the other day, and he basically invented the thing that turned into the TV, and he used it to talk to ghosts. All right, whatever. Any more ideas, suggestions, thoughts?
There's a start towards the atom principle.
Okay, it's a start. A start. No, that's probably a bad example. Okay, so this pen is made, the casing on this pen is made of magnesium. I want to study this casing and I want to know what this is. How do I do that if I don't think about that? If I don't think that this thing is composed of a bunch of very, very, very tiny things, then it's difficult for me to study this thing because I don't know what it is that I'm looking at. Does that make sense? I mean, the first time that we found, that Western society found ancient Egyptian hieroglyphics, where do you even start? You need like something to make sense so that you can build off of other things, right? When you're trying to crack a code, if you can get a piece of the code that you know is correct, then you can extrapolate other pieces of the code. Did anybody see the Imitation Games or read any books related to code breaking during World War II? Does anybody know how they ended up cracking the German codes, the British? Say again? Well, yeah, Alan Turing is the person who came up with the machine to actually do it, because the Germans were using a machine to encrypt all of their information. But what was it?
They took a computer with tubes and dials and they had each do that.
Oh, it was at the bottom, they said Heil Hitler.
Every single message that was encrypted ended in the words Heil Hitler. Once they had a starting point, they realized that every single one of these messages, the last portion of it said Heil Hitler. So now I can check every single message and use that. Those are the letters. And then they extrapolated each of this. Every single message, the code was different. But inside that particular message, if it was long enough, then they could extrapolate certain letters and then they could get it out. And finally, they'll figure out how to crack the code. So they created this machine and it cracked the Germans' machine. For years, we knew what they were going to do. Yeah, we sunk a submarine and then went down hoping that it was still in there, not destroyed. And the person who, I mean, if you have one and your ship or whatever it is that you have is captured or you're captured, then somebody needs to scuttle that immediately. And that person died on the way to scuttling it. So we actually got our hands on one. For some reason, the name is escaping me. It's a good name. Probably in 20 minutes I'll just blurt something out that means nothing, and it'll be that. So the important part here is it's a starting point. If I don't know what matter is composed of, then it's very, very difficult for me to study. But if I know that everything is composed of these tiny atoms, then I start looking at all these different objects and thinking about small atoms, and I can break them apart and study them individually. We found an awful lot of elements after we did this. And we realized that, oh, this thing here that is table salt, it's not one thing. It's two things connected together. And now that I'm thinking about it being one or two or three or five things, I can separate them out and realize exactly what they are. How about this next one about the magnitude of the charge on the proton and the electron? That's not what the question asked.
It's like the proton is like this is one.
What's that word mean, magnitude? What? Big, size, right? So tell me about the size of the +1 and the -1. Okay. Anything else? They're equal to each other. The magnitude of the proton and the electron is they're equal. That's the important part. So if I've got an atom and it's got 10 electrons in it and it's got 10 protons in it, then what's the overall charge of the atom? 0. Everybody cancels out. Okay. Why did this just stop working? Cool. That's going to be problematic. Okay, so this next one, according to Dalton, what happens during a chemical reaction?
Atoms are rearranged.
So all I'm doing is taking atoms that are composing a particular substance and disassembling that substance and putting that substance back together in a different configuration for those atoms. That's it. Why is Dalton happy to know that the chemical formula for water is H2O? It's always H2O. And it's simple whole number ratios, right? It's a 2 and it's a 1. That's the end of it. How about that empty space comment there? Matter is mostly empty space. Okay, the volume of space that the electrons have to navigate through is enormous compared to the tiny nucleus in the inside. Do you remember what it was? What the difference was between the atom size and the nucleus in the center size? It was 5 orders of magnitude. It was 10 to the negative 10th and 10 to the negative 15th. So what's the difference there? 5 zeros, right? So 100,000 times different between the two of them? 10,000 times different between them. All right, so what's the formula for the sulfate? S sulfur and 4 oxygens and a negative 2 overall charge. And the sulfite? Sulfur and 3 oxygens and a minus 2 charge. How about the nitrate? A nitrogen, 3 oxygens and a minus 1 charge. And the nitrate? A nitrogen, 2 oxygens and a negative 1 charge. And the ammonia? Nitrogen, 4 hydrogens and plus 1 charge. Yep.